our goal for today's lesson is to begin graphing our functions, making some graphs. You'll notice if you're a person who flipped ahead in your homework packet, you'll see that you have several graphs to produce for me this evening. Why I start teaching graphing in this way is because it will work all year long. So, before I get too deep into the lesson, I just kind of wanted to give you an opportunity to take a look back at example 4. This was sort of like our conclusion, sort of independent practice at the end of yesterday's lesson. I just wanted to make sure that you had a moment to check it to make sure that you got it right. So lend the screen your eyeballs and make sure that example 4A and B are both correct. Okay, now we got to talk about them. First of all, did anybody miss any of those and not know what they did wrong? Nice. Okay, I need a brave volunteer. We had to respond to 2 prompts in this example, if you recall. The first prompt asked us to decide, is the function linear or nonlinear? How did we make that decision? Do you remember from yesterday's lesson? How did we do that?
Didn't we put it into our calculator and look at it?
Yeah, nice job. So we plugged our equations into our y equals screen, and we looked at the picture the calculator generated, right? So for it to be linear, what shape did it have to make? A line, very good. So if it's nonlinear, it's just not going to make a line. It's not a line. Everybody okay with that? It is going to be helpful for today to have your calculator handy. So while we're continuing our conversation, you can go ahead and dig out your calculator. That was the first prompt. There were 2 prompts in this example. The second prompt had us evaluating a function, and you did this in your homework last night. We had to evaluate the function when x was -3. So can anybody talk to me about how we did that? Miller's off the hook. She already answered. Go ahead, Andrea.
You put x in the equation to solve for y.
Yes. So we put a number in, aka an input, or you said an x value, and we got a number out that was our y value, or our output. Kind of reminding us that functions are like machines. We put something in, we get something out. You got an input, it gives you an output, right? We put in a control variable, we get out a dependent variable. What this gives us, and think about what I did yesterday. I had you write your answer. See it down there? I had you write your answer. This guy right here, for instance, or this guy right here. I had you write your answer as an ordered pair. And that wasn't because it was fun. I mean, it is fun. But what I wanted you to start to think about is that you can put things into a function, get things back out of a function, and it actually gives you a point on the graph. This is now an ordered pair that you would see, and I think a lot of us did, we saw in our table of values on our T-chart on our calculator. So it's super handy. Now, the goal for today's lesson, so I reviewed yesterday's lesson just a little bit. The goal for today's lesson is now to take this information where we're now able to find 1 point, use that same skill to find many points to produce a graph. And my people, we're going to look at some crazy functions throughout the course of this year. Not too crazy. I mean, it's algebra 2. So, reasonably crazy. We're going to look at a lot of different graphs this year. And this method always works. So when in doubt, just produce a T-chart. Make yourself a T-chart, plot your points, and then the rest of it just comes. You know, over the course of this year, and I'll go ahead and let you know, you could talk to any of my Algebra 2 students I've had in the past. Whenever you see the word graph on your homework, you can let out a little groan, because it's almost like those are our essay questions. We don't really have too many essay-type questions in this class, but you're literally teaching me about all of the important points on a graph. So they're a little bit more involved whenever you see that word. So it's fair. I'm not going to give you like 20 to graph. That'd be ridiculous in this class. But the ones that I go after, I want them to be of good quality. So you're going to teach me about every single point on the problem. So let me start showing you how to, shall we? So what we have here is our graphing using a T-chart. My T-chart kind of looks like an H. But in general, why I'm teaching you this at the beginning of our year together is because it is a method that will always work. Okay, step 1. You are going to construct a table of values. When you go to construct your table of values, I have some rules, however. You must choose some positive numbers, some negative numbers, and x equals 0. That's so that you get all of the quadrants potentially, all of the spaces on the xy axis pictured in your response. If you leave off negative values, you're lopping off perhaps one whole half of your graph. If you leave off your, 0, well then you're missing potentially the y-intercept, the place where the graph crosses the y-axis. So neglecting to include positive, negative, or x equals 0 values will result in a response that is incomplete. Step 2, you plot enough points from the table to recognize some kind of pattern or shape. And then step 3, you connect those points with either a line or a curve. When you go to choose your positive and negative values, I always give a little bit of a tip, like pick some easy numbers. And case in point, I'm going to go ahead and talk about this one right here. So that y equals negative 2x minus 2. Picking some easy numbers might involve us just going back to our understanding from Algebra 1, and you might remember this from back in the day. To get some easy numbers, your teachers were just teaching you to do negative 2, negative 1, 0, 1, and 2. Remember those? Whew, good times. So you see, you get some negative values, you get 0, and you get some positive values. But just a little reminder, well, because hey, the numbers aren't always that cute in Honors Algebra 2. What I need to remind you about is the fact that this number here, you see it's a negative 2. Hypothetically speaking, I could turn that into, I don't know, my last class I think I decided, I was like, I'm going to turn that into 2/3 or negative 2/3. Don't write that down. This is just hypothetical. In which case, if I'm taking 2/3 of an x value, you know what I don't want to take 2/3 of? 2. Well, 0 wouldn't be too bad because that's just 0, But if I had to take 2/3 of 2, I'm looking at 4/3, which is 1.333, which isn't even a mark on my graph. So what I say is that, watch your denominator, pick a multiple of that denominator. So see how it's 2/3? My x values would be like 3, 6, 9, or negative 3, negative 6, negative 9, because it's easy to take 2/3 of 6, that's 4. It's easy to take 2/3 of 9, So, just pick some easy numbers. They don't necessarily always need to be negative 2, negative 1, 0, 1, and 2. You're going to have to show this work on your homework tonight. Pick numbers that make life easy, okay? But this problem doesn't say 2/3. It just says negative 2x minus 2. So I'm going to go ahead and now set up that middle column of my T-chart. Oops, sorry. Just spun that around by accident. Setting up that middle column of my T-chart, we have negative 2 times negative 2 minus 2. You see what I'm doing right now? I'm doing yesterday's lesson. I am evaluating my function at negative 2. Evaluating that function at negative 2, and don't forget about your order of operations. I got to multiply before I subtract. Evaluating that function at negative 2 yields, let's see, we got 4 minus 2, so that's 2. And then I have to evaluate that function at negative 1. And then I'm going to evaluate it at 0, and then I'm going to evaluate it at 1, and then I'm going to evaluate it at 2. So I'll have negative 2 times 0 minus 2, negative 2 times 1 minus 2, negative 2 times 2 minus 2. So I get 2 minus 2, that's 0, negative 2. Oh, look, a y-intercept at my b value. Fancy that. And then we got -4. And then we got -6. So we got decreasing by -2. My slope there, -2. And then I can plot these points. So when I plot -2, 2, I go to the left 2 units. This is me plotting. So I'm going to go to the left 2 units. Ooh, that's off. And then up 2 units. So my dot will go right there. We'll throw back to graphing if you haven't done it in a while. -1, 0. 0, -2. 1, -4. 2, -6. And then I can connect these because I see it's a linear function. This method will always work for graphing. All right, are there any questions about that process? So step 1, we made a table of values using some negative, 0, and some positive numbers. I then evaluated that function to get some ordered pairs. I plotted those ordered pairs, connected them with either a line or a curve. And this guy's linear, right? Makes a line. That's fun. We could write that down too, since we're learning what's linear and what's not. Now, you get a little bit of conclusion-independent practice. On number 3, you're going to make a T-chart. So don't forget. I know some of you started on that. I'll show you the answers to this in just a few minutes. Just like you to practice a little bit, see how it goes. Some of you are super quick, and you're going to finish your conclusion activities today super quick. So what I want you to do, if you're a fast finisher, the hard problems on the homework tonight, graphing-wise, where you're making your T-chart, are number 10 and number 12. Number 10 is tricky because it has a fraction in it. Number 12 is tricky because it has you doing the absolute value. And to make your T-chart, you evaluate the absolute value and then you're going to add 1. So I'd like you to try 10 and 12 maybe before you leave. The last thing I wanted to say about the homework is that there's not a ton of space on here for you to put your T-chart down. So what I have to say about that is if you need notebook paper, just make sure you label it 2-1 practice C and you include your T-chart because I'll be checking for those. So please make sure your T-charts are on there. All right? Super important. Big part of today's lesson was constructing those T-charts. So if you want to take a second to check yourself, make sure your conclusion and independent practice is the way it's supposed to look. Don't forget to include your explanation. I still need to check a couple homeworks over there real quick. That's what that's supposed to look like.